Okay, so we're on to the final video now. We're going to go through some your turns for 8E. What have we got? No, I don't want that one. I don't want that one either. So we've got acceleration here. Acceleration is given by this, and then we've got a piece of information, which is probably to help us integrate. So speed, so we want to find v to start with. So we're going to integrate acceleration with respect to time. So that's going to say that v equals then what? That's 5 over 2t squared. I'll just check I've got my notes for this as well. Oh, that's the I, isn't it? That's it. And then for the other one, you end up with minus 10t to the 3 over 2. So if you multiply it by, is that right? What have I put? Yeah, okay, right. So you should get that one there. So 2/3 of 15 is 10. Yeah. Let's jump right in and let's do the C's. So you really do have to remember these. It's very easy to forget. It said at t equals 0, the velocity is 20. So you've seen now from the previous couple of videos that because you're integrating and these have t's already, we can actually safely say that C1 is going to be 20 and C2 is going to be 0. Okay, and if you plug those numbers in for yourself, you will see that. Yeah. So then what do we need to do? Then we need to find the velocities at t equals 4 for both of these. So you're going to do 5 over 2 t squared plus 20, where we put 4 in there, and then also the same for this one here. Okay, so at t equals 4, that should give you, pardon me, that should give you 60 and minus 80. And then it says speed, which is out of magnitude. So we want to do a 60 squared plus an 80 squared. And that will in fact give us 100. It's a speed, 100 meters per second. Not bad at all for 6 marks, that one there. And then the harder questions. So let's go on to the harder question. So it says particle P has got, so for particle P, let's write this down. So for particle P, we've got a velocity, which is 40 minus 5 and 3. At t equals 0, the position vector is this. Okay, so these are going to be, like we've just said, because it's t equals 0, that will be our C1 and our C2 value. Find the value of t when the velocity is parallel. Velocity. Okay, so I'm nowhere near integrating yet. There's something else going on. So parallel to J means that the thing is going up or down, doesn't it? So why is it only 1 mark? Am I meant to spot something nice and quickly? So yeah, I think I am. I meant to spot that if it's going up or down, it means there's no left or right in it. So it means that this bit here must be equal to 0. So 40 minus 5 is equal to 0 when t equals 5 over 4. There we go. Find an expression for the position vector. Okay, this is the integration one, isn't it? So I want to integrate the velocity with respect to time, which is going to be what then? So it's going to be a 2t squared minus a 5t. And we had some values here already, didn't we? So I can also just jump to saying plus 2 in this case, and the other one is going to be, is that 3t, and plus 5. So a bit of a shortcut. That shortcut only works because it's t equals 0. Otherwise, that wouldn't work. Yeah. That is the expression though. So second particle is another particle. And this has a constant velocity. Okay, so this is a throwback, isn't it, to the start of the chapter. So when we had a constant velocity, what we often used is we used this one here, we said where it is where it started plus, where it's going, that sort of idea. I wonder if we want to use this one here. So when t equals 0, yeah, that's the r0 bit. So it seems like they want us to use this one here. So let's say r equals 11, 2 plus the constant velocity is a -2 and c times t. So that's the general way of describing where Q is. And then we've got a general way of describing where P is over here. The particles collide at a point with position vector here. Right. So what's the best way to do this one? 5 marks. So many bits of information, what to do. Well, we could make a couple of, I suppose I don't know it right. I think I know a bit more over here. So let's try using this 14 first. So we know that 2 plus CT equals 14. And we also know that 3t plus 15 equals 14. So if we use the 3t plus 5, not 15, sorry, 5 equals 14, we can get from that what? We can get that t should be equal to 3. And then we could use it on the bottom line on this one here. So we could say, so 2 plus CT is 3C, isn't it? That also has to be equal to 14. So C must be equal to, not 12, that's before you divide it, that's 4, isn't it? So C is equal to 4. Okay. And now we know that, it sort of cracks the thing open a little bit. They want to know the value for the i's. So could I just use this one here? Yeah. So 11 plus, minus 2 lots of, what's the time value? 3. So that should just be 5. Is that right? Yeah. Okay. So, or d equals 5. So that one there is it's a bit difficult because you've got so many different bits of information in front of you, but just trying to work out which ones you need. Notice that the constant velocity one was from 8a, this format here. It would not have been appropriate for this one over here. And for the I and J one, which we sort of looked at as variable acceleration over here, we just handled it by differentiating and integrating was the main way. So there we go. That takes you through to the end.